Imagine walking outside tonight and looking up. The moon is there, as always. But stretching across the entire sky from horizon to horizon is a band of light so bright it turns midnight into permanent twilight. A glowing arc of rock and dust, wider than your outstretched hand, carved across the stars like a scar. That's what Earth would look like with rings. Not Saturn's delicate ice ribbons, something rougher, grittier. A belt of stone and debris, baked by a sun that's 8 times closer than Saturn's. No ice, no shimmer. Just billions of rocks, from grains of sand to chunks the size of apartment buildings, locked in orbit around our planet. And unlike anything else in the sky, they would never move, not from your perspective. The rings would sit in exactly the same spot every hour of every day for your entire life. They wouldn't rise, they wouldn't set, they'd just be there. A permanent fixture like a mountain range painted across the heavens. But here's where it gets interesting. What those rings look like depends entirely on where you're standing. Let's take a trip. If you're at the equator, say Quito, Ecuador, you'd see the rings edge on. A razor-thin line of light shooting straight up from the horizon, splitting the sky perfectly in two. You might not even realize what you're looking at. Just a vertical stripe of glow, like a cosmic searchlight. Now fly north to Washington, D.C., about 40 degrees latitude. Here the rings tilt into view. They become a massive glowing arch, sweeping from east to west, wider than any rainbow you've ever seen. At night, they'd outshine the full moon by a factor of 10. You could read a book by ring light alone. Streetlights, redundant. The concept of a truly dark night would simply cease to exist. Head further north to Reykjavik or Tromsø, and the rings sink toward the horizon, a low, shimmering hump. Still visible, still enormous, but more like a distant glowing wall than an overhead bridge. And in the Arctic, just a faint glow on the southern horizon, a rumor of light. Every civilization on Earth would have built its mythology around this thing. The Greeks would have called it the Bridge of the Gods. The Polynesians might have navigated by its angle. Imagine the cathedrals that would have been built to align with it, the calendars based on how its shadow shifts. Entire religions founded on the question of why there's a permanent road in the sky that nobody can walk on. But let's talk about that shadow, because this is where beauty becomes a problem. Since the rings sit directly above the equator, they cast a shadow. A permanent, sharp-edged band of shade that moves across the Earth's surface as the planet tilts through its seasons. During the equinoxes, when the sun crosses the equatorial plane, its light has to pass through the ring, and the tropics get plunged into a partial eclipse that lasts for weeks. Think about what sits in the tropics: the Amazon rainforest, the Congo Basin, the coral reefs of Southeast Asia, the rice paddies that feed half of humanity. All of them sitting under a strip of shade, receiving significantly less sunlight for weeks at a time, twice a year. Researchers estimate that depending on the density and width of the rings, global temperatures could drop by 1 to 3 degrees Celsius. That doesn't sound like much, but for context, the last time Earth's average temperature dropped by about 4 degrees, we got the last ice age. Glaciers covering Canada down to New York, sea levels 100 meters lower than today, entire ecosystems that no longer exist. 1 to 3 degrees from a ring shadow is enough to rewrite the map of where food grows, where civilizations flourish, where life itself can hold on. But the shadow does something else, something more personal. It changes the sky. Right now, if you live in the tropics, you get the best view of the Milky Way, the darkest skies, the most visible stars. With rings, forget it. That glowing band would wash out everything behind it. A bright, permanent stripe blotting out a huge section of the night sky. Professional astronomers would have to relocate to extreme northern or southern latitudes, the only places where the rings sit low enough on the horizon to leave some dark sky overhead. Hubble, the James Webb Space Telescope, their entire observation strategy would have to account for permanent obstruction. and it gets worse for anything in orbit. Every spacecraft in low Earth orbit would have to dodge ring particles. The International Space Station, GPS satellites, weather monitoring systems, all of them threading a needle through a belt of debris moving at 28,000 kilometers per hour. A single pebble at orbital velocity carries the energy of a hand grenade. Every launch window becomes a gamble. Space travel doesn't just become harder, it becomes a constant negotiation with a minefield that never goes away. Now here's the question that turns this from a thought experiment into something real. Could Earth actually have rings? Saturn's rings exist because they sit inside something called the Roche limit. That's the distance at which a planet's gravity is strong enough to rip a moon or asteroid apart. Get too close, and tidal forces tear you to pieces. Those pieces spread out into a flat disk, a ring. For Earth, the Roche limit sits roughly 18,000 kilometers from the center, about 11,000 kilometers above the surface. Well within reach, but there's a problem. A big, bright, cratered problem hanging in the sky right now. The moon? Our moon is massive, 1/80th the mass of Earth. Its gravitational pull would destabilize any ring system over geological time. The same tidal forces that give us ocean tides would tug on ring particles, pulling them out of their orbits. Some would spiral inward and burn up in the atmosphere. Others would be flung outward into deep space. Over millions of years, the moon would clean house. Earth can have rings, or Earth can have the moon. It probably can't keep both, which is exactly what makes the next part so strange. 466 million years ago, in a period called the Ordovician, the Earth looked nothing like today. No trees, no land animals. The continents were in different positions. Life was almost entirely in the oceans. Trilobites, girly corals, jawless fish. And something happened that left the mark we're still finding today. An asteroid drifted too close. It crossed Earth's Roche limit, and it came apart. Not in a dramatic flash. Slowly, over days, maybe weeks. Tidal forces stretched it, cracked it, pulled it into thousands of fragments. Those fragments spread out, collided with each other, flattened into a disk, and for a while, maybe a few million years, Earth wore a belt of debris. A ring of rock circling the planet above the equator, invisible from the surface at first. Then, as the fragments spread and caught the sunlight, a faint band appearing in the sky, getting brighter, getting wider. We know this because of the craters. 21 impact sites from this period have been identified around the world. And here's what caught scientists' attention. All 21 of them sit within 30 degrees of the equator. That's wildly improbable. Over 70% of Earth's continental crust lies outside that band. If space rocks were falling randomly, you'd expect craters scattered across every latitude. But they're not. They're clustered in a narrow strip exactly where debris from a ring would spiral inward and fall. And the evidence goes deeper. Limestone layers from this era, found in Sweden, China, and Russia, contain 100 to 1,000 times more meteorite dust than normal. Not a single impact, a slow, continuous rain of particles from orbit lasting millions of years. And what followed was devastating. The period after this ring formation aligns with the Heinentian Ice Age, one of the coldest stretches in the last 500 million years. Global temperatures plummeted, oceans cooled, up to 85% of marine species were lost. And scientists now suspect that the ring's shadow, blocking sunlight over the tropics for millennia, may have helped push the planet over the edge. Earth wore a ring once, and it reshaped the planet. The trilobites crawling along the sea floor had no idea what was happening overhead. They just knew the water was getting colder. The light was getting dimmer. And then slowly, their world started to end. So the next time you look up at the night sky, consider this. Rings are not just beautiful. They are engines of change. They reshape climates, redirect evolution, redefine what a civilization can see and where it can grow. And right now, Saturn's own rings are reminding us of something. In March 2025, They turned edge-on to Earth for the first time in 15 years, almost vanishing from view. The most iconic feature in the solar system, reduced to a razor-thin line. Gone from our telescopes, just like that. The next time we'll see them this thin is 2038. And here's the thing that most people don't realize. Saturn's rings might not be permanent at all. They might be a temporary feature, not a defining one. Cassini data suggests they could be gone entirely within 100 million years. Ring rain, particles slowly spiraling inward, is draining them. What we see when we point a telescope at Saturn might be the rings in their final act. Earth's ancient ring lasted maybe a few million years. Saturn's might last 100 million more. In cosmic terms, rings are temporary. Beautiful, powerful, world-changing. But temporary. Cosmic jewelry with an expiration date. Maybe that's the real lesson. The universe builds stunning things, and then piece by piece, rock by rock, it takes them apart. If you could bring back Earth's ring for one night just to see that arc of light stretching across the sky over your city, would you do it? Knowing what comes with it. The shadow, the cold, the slow unraveling of everything underneath. Tell me in the comments. I genuinely want to know what you'd choose. And if this is your first time drifting with us, hit subscribe. We do this every week. New deep dives, new animations, and the kind of questions that keep you staring at the ceiling at 2 a.m. Tune in and drift with us.